Hello everyone, welcome to the channel. So in this video I'm gonna show you boosting Sentinel-2A image resolution to 1 meter using Gamma Earth in Google Colab and visualize the image in ArcGIS Pro. So now let's get started. So boosting Sentinel-2A image resolution to 1 meter using Gamma Earth AI. So the Gamma Earth is a sophisticated geospatial analytic platform that leverages the power of artificial intelligence and satellite imagery to deliver an actionable environmental intelligence, enabling the business, government, and organization to monitor and manage the planetary scale changes with unprecedented speed and accuracy. By harnessing a vast datasets from sources like Sentinel, Lancet, Planet, the platform automates the complex process of analyzing the Earth observation data and transforming it into a clear, actionable insight on critical areas such as deforestation, agricultural productivity, carbon sequestration, and urban developments. So, its core strength lies in applying the specialized AI model to detect, classify, and quantify the specific phenomena over time, which allows for tracking the forest loss, assessing the crop health, and monitoring the methane emissions and evaluating the disaster impacts without the need for the manual on-ground surveys. This technology is crucial for driving the sustainability initiatives as it provides a transparent and verifiable data for carbon credit verification and supports regulatory compliances and enhances the supply chain transparency and empowers the strategic decision making for more sustainable and resilient future. And this is the official website of Gamma Earth. So environmental intelligence, uniquely powerful AI solution for Earth observation and remote sensing. So you can able to see the below given details here. The super resolution, up to 10x increase in spatial resolution with reconstruction of spatial features, textures, and accurate spectral characteristics. And it also provides a cloud removal, seamless detection and removal of cloud and cloud shadows from optical, multispectral, and hyperspectral satellite imaging data. So we can also take a look at this particular its capability. For example, I'm going to click this option called See Demo. So here we're going to take a look at the imagery. This is the Sentinel-2A imagery versus the after. This is the image after applying the Gamma Earth AI. So you can able to see the clear difference between the two images here. So the Gamma Earth AI uses a different set of imageries, for example, Planet Scope and Lancet and Sentinel imagery to process this high resolution imagery. So you can able to see the clear difference between the normal Sentinel imagery versus after applying the Gamma Earth AI. So you can able to see the difference here. And similarly, second example, we're going to click this option here. This is our second example. I can able to see the difference here. So this is the normal Sentinel-2A imagery versus the after applying the Gamma Earth AI. So we can able to see the difference here. So now we're going to navigate to the Google Colab here. So I'm going to open my new browser here. And in the browser, I'm going to enter as Google Colab. So once you entered Google Colab, I'm going to click enter. And I'm going to click the first result here. So I'm going to click this option, Google Colab. So now here you can able to see. Let me close this. So I have already signed into the Google Colab here. Make sure that is sign in. And here you can able to see the welcome to Google Colab. Access popular LLM via Google Colab AI without API keys. So now to create a new notebook here, first I'm going to navigate to the file section, and in that I'm going to click this option called new notebook in the drive. And once you did that, it's going to load the. So now here you can able to see it is loaded the Google Colab interface here. So now here first step I'm going to navigate to this option called untitled here. So I'm going to enter my title. So here you can able to visualize. I've entered as boosting Sentinel-2A image resolution to 1 meter. So I have given as a title boosting Sentinel-2A image resolution to 1 meter. So in the next step, so once you've given the title for it, in the next step I'm going to open my Google Drive here. So we're gonna click this option called New Tab. So once you entered as the Google Drive here, so we're gonna click Enter. I'm gonna search it, and here I'm gonna navigate to this option called Google Drive Sign In. And once you've signed in, I'm gonna navigate to this top section, and I'm gonna click this option called Drive. So once you're inside the Google Drive here, so the next step I'm gonna navigate to this option called New. So I'm gonna click this option called New, and in that I'm gonna click this option called New Folder. So in the new folder I'm gonna enter as Sentinel-2A. So here I'm gonna enter the name as Sentinel-2A AI. So I've entered as Sentinel-2A AI, and I'm gonna click this option called Create. So you can able to see the folder appears here. So once the folder appear, I'm gonna navigate to my Google Colab bar here. So once you're inside your Google Colab here, so in the next step I'm gonna navigate to this option called Files. So I'm gonna click this option, and in that I'm gonna click this option called Mount Drive. So I'm gonna click this. So now I'm gonna click this option called Connect to Google Drive. So once you click this option, so you can able to see this option here in the below here. So mounting Google Drive, it appears. And in case if it asks for access to the Google, so if it asks for the access to your Google account, make sure that you click accept. So in the next step, we're going to configure our Google Colab environment here. For example, I'm going to navigate to this to the bottom section here called Python 3. So I'm going to click this option, and in that I'm going to click this option called Change Runtime Type. So I'm going to click this option. So now a new window pop up saying change runtime type here. So make sure that the runtime type is Python 3, and in hardware accelerator, make sure that you click T4 GPU. So make sure that you click this option called OK, and let me save this. So now here you can able to see it is initializing the T4 GPU. So now we are configured to our T4 GPU here. So you can able to see this option T4 GPU Python 3. So once it appears in the next step, so the next step is we're going to link our Google Drive folder where the result will be saved. So to do that, first I'm going to copy this particular code here. So I'm going to copy using Control C, and this particular document will be given in the description of this video. So we're going to copy this particular code using Control C. So once you copied it, so I'm going to paste it inside the Google Colab environment. For example, I'm going to paste it here. So I'm going to click Control V. So we are basically what we are doing is we're going to link the Google Drive folder where the result it's going to be saved. So our folder name is Sentinel-2A AI. So let me show you that. So folder name is Sentinel-2A AI. So make sure that you enter the folder name here. So Sentinel-2A AI. I'm gonna change this to 1 meter to AI. So once you entered that, so once you did that, we're gonna click this option called Run to execute this code. I'm gonna click this. So you can able to see the tick mark here. So the code has successfully ran. So the next step is I'm gonna install this particular package. You can able to see this particular package, install S2DR3 package for Sentinel-2 image processing. So this particular package is going to help us to reduce improve the resolution of the Sentinel imagery from 10 meters to 1 meter. So this particular package is provided by the Gamma Earth. So we're going to copy this particular code here using Control C, and I'm going to navigate to my Colab environment. So here I'm going to click this option called the code, and I'm going to paste it inside this. So using Control V. So once you pasted this code, again we're going to click this option to run this code. So it's going to load the package here. So it's going to take some time to load this particular package. So it's going to take less than a minute to load this package. So the next step, once the package has been loaded, in the next step, we're going to fix the coordinates here. For example, we're going to import this particular package here. After that, we have to select our suitable study area location. For example, so we have to give a latitude and longitude. So we have to give our longitude as well as our latitude of our study region. And after that, we have to give the date of the Sentinel-2A image to process. So particularly, I'm going to select an image with the least cloud contamination time period. So we're going to select some suitable time period. And in the last step, we're going to process the image and generate our 1 meter resolution product. So to do that, I'm going to copy this set of code here using Control C. And once you copied it, I'm going to navigate to my Colab environment. So here I'm going to click this option called code. And here I'm going to paste the code here using Control V. So once I've pasted my code here, so the next step I'm going to open the Copernicus Hub website here. So I'm going to enter in the search section as Sentinel Hub, and I'm going to click this option called search. And in that, we're going to select this particular one called Sentinel Hub Copernicus Data Space Ecosystem. So I'm going to select this. And once you selected it, we're going to navigate to this option called Explore Data. So this is the Copernicus browser here where you can download your Sentinel-2A imagery. So I'm going to use this particular browser to find the most a suitable period of my study region with the least cloud contamination. So first I'm going to navigate to my study region here. So my study region lies in the Chennai here. So I have navigated to my study area here, so you can able to see that. And this is my study region. So the data is still loading. So this is my study region. You can able to see that. So now in the date, you can able to see the date here. So I'm going to select this particular option called date single. So I'm going to click this. And now I'm going to find my suitable time period. So for example, I'm going to select this particular month called the July. And these are the following imagery that is available for this month here. For example, I'm going to select on this particular time called 8th of July 2025. And it's going to load the image here. So you can able to see it's loading the image. So once the image has loaded up here, so you can able to see here. So this particular image has no cloud contamination here, and you can able to see here in this particular date it has a cloud contamination of around 30%. So for my study region, it has a lower no cloud contamination for this particular study area. So in the top section here, you can able to see here in this section here, we have our latitude and longitude of a study region. For example, the latitude, it is given around 13.0735. So I'm going to copy this 13.0735 using Control C in my keyboard, and I'm going to navigate to my Colab environment. So I'm going to select the Colab environment, and in that you can able to see the coordinates of Chennai, India. So we're going to paste my latitude here, value of my latitude using Control V. So now I've pasted the latitude value. Similarly, I'm going to navigate to my Copernicus browser here. I'm going to copy the longitude here. So you can able to see here, it has given the longitude value to here. So we're going to copy the longitude value, that is 80.25169. So we're going to copy using Control C. So once you copied it, I'm going to navigate to the Colab environment, and I'm going to paste it on this particular value. This is a longitude value. I'm going to paste using Control V. So once you pasted the coordinates of your study region, so the next step we have to fix the date of the Sentinel-2A image to process. So for example, so I have selected this particular date, that is 2025/7/8. So I'm going to enter this particular value. So I'm going to enter this particular date in my Colab environment. So you can able to see. So we're going to paste the particular value. So it is 2025, and the month is 7, and the date is 08. So now I have added my date of my Sentinel-2A image to process this particular image to convert this image to a 10 meter to a 1 meter resolution image. So this is a date for that. So in the last step, we're going to process this image and generate a 1 meter resolution product. So for that, we're gonna mention S2DR 3 dot infirotils. We're gonna mention this particular one, and dot test the latitude and longitude and latitude and the date. And this particular the package which gonna give us a 1 meter resolution image. So the image will be a 4 by 4 kilometer around this coordinates of this given coordinates. So it's gonna give us a 4 by 4 kilometer image around this coordinates. So now let us run this code here. So I'm gonna click this option called run the cell, and it's gonna execute this particular code, and it's gonna give us a 1 meter resolution Sentinel-2A imagery. So you can able to see currently it's fletching model. So you can able to see the percentage here. And this particular has some limitations here. For example, the processing limitation. So something important you should know is that the model process an area of 4 by 4 kilometer around the coordinates you specify. So this means that if you need to cover a larger surface, you will have to do more multiple runs with different coordinates, or request access to the full API that will allow you to process much larger area. And the result generated will be when processing is complete, you will find 8 TIFF files in your drive folder. So 2 versions of each type is generated, one with the original resolution and another is improved to 10 meters. So I recommend you to download the file that is ms.tiff larger in size, because it contains a complete multispectral image with the 10 bands. So let me get back to Google Colab here. So currently it is post processing, so you can able to see here. So now here you can able to see the code has run here. So currently it is generated this particular image. So this is the Sentinel-2A imagery of 10 meter resolution, and this is the Sentinel-2A of imagery of 1 meter resolution image. So we have generated it. So we're going to click this code here. So we're going to click this to visualize it in map box. So you can able to see the difference here. So it's loading the image here. So we're going to wait for a few seconds. So it's going to load the image. And in our right side here, you can able to see this is our Sentinel-2A of 1 meter resolution, which is generated by the Gamma Earth AI. So we can able to see the difference here. So it's going to load the final true color image. So we can able to see the difference now more clearly. So this is our Sentinel-2A of 10 meter resolution versus the Sentinel-2A imagery of 1 meter resolutions. So this is the difference between the two. So the model has generated a high resolution imagery of 1 meter Sentinel-2A imagery. You can able to see the difference here. So it's basically this AI model has used a different satellite imagery, for example Landsat, Sentinel, and the Planetscope imagery to generate this the high resolution Sentinel-2A of 1 meter resolution. So you can able to see the difference here. So you're gonna zoom here. So you can able to see the difference. So now let me get back to Google Colab. So we're gonna save this particular file. So we're gonna navigate to this option called Files, and I'm gonna click this option called Save. And in the sample, you can able to see this this particular folder called Output. So we're gonna click this folder. So we're gonna click this. So we have this set of data. So I can able to see the different image has been generated from this AI model here. So we have this NDVI, this is the multispectral imagery, and TCI and IRP, and these are following images are georeferenced image. You can able to see. So let me show you in my drive here. So inside my drive, this is our folder Sentinel-2A AI. So I'm gonna click this folder. I'm gonna navigate inside this folder, and you can able to see this. These are the following set of imagery it has generated here. So you can able to see all this imagery and its size here. So you can able to see that. And you can able to see from this image here. So this is the original Sentinel-2A of 10-meter resolution image, ms.tiff, so of 3 MB. And similarly, we have this another image called ms.tiff, which is of 276.4 MB, which is a 1-meter resolution imagery. So we're gonna download it. So I'm gonna navigate to this Google Colab, and here I'm gonna select this particular image. I'm gonna select these 3 dots, and I'm gonna click this option called download, and it's gonna download this image. So now I'm gonna navigate to my suitable folder location. So I'm gonna click save, and it's downloaded. Similarly, I'm gonna download this particular imagery. I'm gonna click these 3 buttons. I'm gonna click download, and I'm gonna navigate to my folder locations. So now navigate to suitable folder location. So I'm gonna click save. So it is downloaded the files here, and make sure that I'm gonna save this so now we're gonna open both the images in ArcGIS Pro, and let us visualize the difference. So I'm opening the ArcGIS Pro. So we're gonna visualize both the image, the 10-meter versus the 1-meter Sentinel-2A imagery. So now I have opened my ArcGIS Pro. So I'm gonna add both the images. So I'm gonna select both the image here, and I'm gonna right click and click this option called add to current map. So we have loaded both the images here. So let us take a look at this image. So first, we are currently visualizing our Sentinel 10-meter imagery, and let us visualize our high resolution 1-meter Sentinel-2A imagery, which we generated using Gamma Earth AI. So you can able to see the clear difference here. So let me turn this on. You can able to see the difference here in the resolution. So you can able to see the individual build-up areas here compared to our previous 10-meter imagery. So actually we have a very good output here. So you can clearly able to see the difference here. So now let me get back to Google Colab. So in this video I have shown you boosting Sentinel-2 image resolution to 1 meter via Gamma Earth AI in Google Colab, and last we visualized this image in ArcGIS Pro. So thanks for watching, and make sure that you subscribe to our channel and give us a like.